I
Hey, there we go. All right. I would like to introduce Alan Journet, and he's a adjunct faculty member in the Department of Environmental Science Policy and Sustainability at Southern Oregon University. And Dr. Alan Journet is also involved in many other things, including uh, Southern Oregon Climate Action Now. I think a very uh, important and successful volunteer organization regarding climate change. And Alan has spent, I think, quite a bit of time preparing a talk for us. And Alan said that if we want to have any questions during his presentation, please ask him. So with that, Alan, it's up to you.
Okay, thanks very much indeed, Mike. It's a pleasure to join you to give a presentation on a topic that's very near and dear to my heart, and that's climate climate issues. As you can see from Southern Oregon Climate Action Now, as Mike said, Kathy Conway, my wife, and I are co-founders of this organization, and we now serve as co-facilitators. So when Mike asked me to do a presentation, I actually started pulling some slides together to do the presentation, and I ended up with over an hour of presentation. And so I suggested to Mike that maybe we should either have an extra long meeting, or I should maybe do a couple of programs. And so I'm starting today on climate trends and projections. And then in January, I'll be back to look at the implications of these trends. So I'm not going to get into the implications today. That's a teaser for next year even. So let's start the ball rolling. I'm going to show you a bunch of slides, and Mike had a chance to preview the slides and was thrilled to see so many graphs. I do this presentation, and often when people are enjoying my presentation, they end up afterwards saying so many graphs. But I am a graph person coming from a background in science. So I have to say I'm not an engineer. So I'm going to show you a whole bunch of slides. Most of them, I think, in fact, pretty much all of the graphs came from one of two sources. One source is the National Oceanic and Atmospheric Administration, and the other is the U.S. Geological Survey. And I'll explain what the slides are doing as we go through. So what we're looking at now is a graph which you can see is a graph of the historic temperature of Oregon and over the period 1895 to 2024, what you can see pretty clearly. And I'm guessing, as Mike suggested, most folks here are pretty familiar with seeing graphs. And you can, I think, if you have spent any time looking at data graphs, you will clearly recognize what's happening here. But just in case it's not all that obvious, we'll put the trend line on there, and you can see very clearly that what we have experienced in Oregon historically over that period, 1895 to 2024, is an increase in temperature. And what you will see up here, can you see my cursor?
Not right now.
Okay. Well, if you look in the top right-hand corner, um, you'll see 1895 to 2019 trend, and that is at a 0.2 of a degree Fahrenheit per decade. So over that long haul, the average trend has been of 0.2 degrees per Fahrenheit per decade. But one of the things that happens when we look at graphs such as this, and it really doesn't matter where we are looking, whether it's global data or US data or Oregon data, what you see is the trend to increasing temperature really picked up around the 1980s. And so somewhere around here, you can see the temperature really started to take off. And when I'm showing this graph or a graph like this, I will often say to people, if we take ourselves back to somewhere around 1980, somewhere around this point, we would see a graph with a slight rise, but I think it would be reasonable back then to look at the data and say, well, I'm not convinced that there's any dramatic uh, global warming taking place. I think it's not very convincing to make such a case now because since 1980 to 1985, the pattern has been one of quite substantial temperature increase, and that's what has pushed this per decade average of 0.2 degrees Fahrenheit per decade. That's pushed that up from what it would have been had we done this in 1980-85. If we look at the historical precipitation trend for Oregon over the same period, what we can see is there's pretty much not a trend. There may be a slight increase in the amount of precipitation. The red line is the 5-year mean, and the blue line is the overall trend. And what we see if we come over here to the indication of what that trend is, I can see 0.06 inches per decade, so it's not much of an increase. I would be inclined to say, if anybody who's done any statistics will understand, if you throw a regression line analysis on a set of data, it will always give you a line, but the fact that it gives you a line that's not horizontal is not convincing evidence that this is a significant trend. So having looked at a whole bunch of data myself, I would be inclined to say, yes, that line is increasing at that really slow pace, but I am not convinced that it's significantly different from a flat line. One of the things that you might see from these data, this is very interesting. I've shown graphs like this to students, high school students, and I remember very early on that pretty much the first time I did this, I just threw the graph up, and I asked the kids, so do you see any trends? And one of the things that they noticed, and at that point I hadn't noticed this, there seems to be, as we look at more recent data, say maybe from 1995 onwards, what we're seeing is potentially an increase in the range of the data. There's much more variability, so the peaks seem to be getting higher and the troughs may be just a little lower. And so what that means is that over recent years, the wet years are potentially a little wetter and the dry years are potentially a little drier. But overall, no trend in the average annual precipitation, and I'll talk more about that a bit later on. So now I want to take you into projections into the future. And in order to do that, I want to clarify what on what basis these projections are calculated. One of the things most folks who've spent any time with projecting into the future will realize is that what the future looks like depends entirely on the inputs into the models. And so that's one of the reasons why you will hear climate scientists, and I will confess I am not a climate scientist. I'm a biologist by training, and I will get into that more next month when I talk about implications of all this. And I'll explain that that's what got me energized about the whole climate arena. But when we look at the projections, the way the projections play out is a function of what variables we feed into those models. And so there are a couple of brands of scenarios that have been used. In the Intergovernmental Panel on Climate Change's Assessment Report 5, which came out in 2014, my goodness, 11 years ago now, what they used were what were called representative concentration pathways. And what these represented at that time were the concentration of greenhouse gases anticipated in the atmosphere based on an array of scenarios, and what those concentrations of greenhouse gases would do to the temperature. Now, by 2021, when Assessment Report 6 came out, what had happened was the folks developing these scenarios had, in addition to developing an array of future greenhouse gas atmospheric concentrations, they had developed some socioeconomic bases for those different concentration models. And so now we use what are called shared socioeconomic pathways, or SSPs. And what happened was the modelers simply took the same models that were used in the RCP development, and they gave them human behavior backgrounds. So each of the RCPs became one of the SSPs. And so SSP1, you can see here on the right-hand side, was RCP 2.6. And what that does, that future scenario is based on the expectation that we have a very low level of greenhouse gas emissions. In other words, we are smart enough pretty much immediately to stop emitting greenhouse gases. At the other end of the range, there is what was called RCP, Representative Concentration Pathway 8.5, and that is a future in which there is a rapid increase in greenhouse gas emissions. And so that became Shared Socioeconomic Pathway 5-8.5 to indicate it was RCP 8.5. When that model was, scenario was first developed, it was described as the worst case scenario because it was based on the assumption that we pretty much do nothing to address the problem. We just keep going at our accelerating rate of fossil fuel use, and therefore an accelerating rate of greenhouse gas emissions. So it was thought, when that was developed, there's no way we're going to be stupid enough to do that. Well, as time progressed and people started following what's actually happening with the real world data, it turned out we were pretty much on the worst case scenario trajectory. And so that RCP 8.5 or SSP 5-8.5 started to be called the business as usual scenario. But the key thing to remember when we are looking at projections into the future is we're going to be looking at SSP 5 projections. But the point to remember is, again, we don't have to be that stupid. We don't have to follow the worst case scenario. There are intermediate scenarios. There's RCP 4.5, which became SSP 2-4.5, and that represents an ambitious reduction in emissions trajectory. We're still increasing our emissions trajectory, but it's nowhere near as bad as 8.5. And then there's an RCP 6.0, which became SSP 4-6.0. That also assumes we are exhibiting a smarter behavior. We're reducing the accelerating rate of the increase in our fossil fuel use and greenhouse gas emissions, but it's less ambitious than RCP 4.5. So does that all make sense to folks? Does anybody have a question on that before we proceed to look at some graphs? Everybody's gone incognito, so I can't see if you're putting your thumbs up. So I'll let Mike give me a sound. Yeah.
Alan, do you think we're on for example, SSP4?
I think we're still somewhere maybe between SSP4 and SSP5.
Okay.
I don't think there's been across the globe, and particularly not in this country, of course, there has been a serious enough attempt to reduce that trajectory. In fact, what we're seeing right now, of course, is an administration that's actually discouraging a transition to what I would call a more sensible trajectory and encouraging the ongoing and accelerating use of fossil fuels. So we have an administration that's trying to keep us on the worst case scenario track in this country. Is that fair enough, Mike?
Yes, understood.
Okay. Okay, so what we're going to do is look at some United States Geological Survey climate change viewer graphs. They employ some 20 of the models that are out there, and they report the sort of median or average of those 20 models. And so they happen to be reasonable. Okay, so let's look at Oregon's average temperature projections to 2100. And what you're seeing is the darker red orange line is the SSP5 median. The SSP3 median is in lighter orange, and then the blue is the SSP2 median. And what you can see is if we were to follow that worst case scenario future, we're looking at a rise in average temperature of Oregon.
You think you've had it for 10 years now?
Okay,
Hey, hey, Robert, can you mute, please?
Almost 10 years.
Yeah, just a sec. I got a lot of background noise. I thought I was muted. Let me bear with me here.
Okay.
Just a minute.
Okay. Okay, so if we were to follow that, and in a moment I'll show you the change in temperature patterns, but you can see a rise from 1950 to 2000 of something like the average was some 45 degrees. We're looking at it increasing by 2100 up to over 55 degrees Fahrenheit as the average Oregon temperature, which I think is quite a stunning increase. And I'm going to ask you to retain in your mind that extent of increase, because when I start talking in January about the implications, I'm going to be showing you what the biological significance of that kind of increase in temperature is. And so if the range, the median puts us up at about what, 56, 57 degrees, but the extreme could be up way over 60 degrees. So this is for the average Oregon temperature by 2100. A little disturbing, I think you'll agree. Now, what I am showing you here is exactly what I just promised. This is now the change in temperature from a baseline of 1981 to 2010 average. So what you can see here is a potential increase of some 11 degrees Fahrenheit or over 6 degrees centigrade if we follow again. I'm going to try and keep stressing this because it's very important. Because when we look at these data, it's very disturbing, I think, especially if you understand the biological implications. But the point to remember is, again, we don't have to follow that trajectory. We know how to adjust our behavior to reduce that severity and get us at least on the blue line, which, as you can see here, it would only give us about what, a 5 to 6 degree Fahrenheit temperature increase, which is not good. It's bad enough, but it's not as bad as 11 degrees Fahrenheit. Now, those data that I just showed you came from the United States Geological Survey. OCRE is the Oregon Climate Change Research Institute, which is based on the campus of Oregon State University. This institute was established in 2007 by the same legislative bill that gave Oregon a trajectory, a hope for reductions in greenhouse gas emissions trajectory to 75% below 1990 levels of emissions by 2050. That bill established the Oregon Climate Change Research Institute, and it put us on a voluntary emissions reduction trajectory. The problem with that, of course, is it was voluntary, and so anybody who pays any attention will probably know how effective a purely voluntary set of targets is. What happened was the businesses that are in Oregon that are largely responsible for the greenhouse gas emissions simply didn't rise to the task of reducing their emissions. And so Oregon never got on that trajectory. But the OCRE, the Oregon Climate Change Research Institute, is charged with producing every 2 years an Oregon climate assessment report. And so this comes from, let's see if we, this I think is the most recent Oregon climate assessment report that came out, I think, last year. And what you can see here is projections which are essentially the same as what we were looking at from the USGS. Notice they are using this, they're using SSP 2, 3, and 5. And if we look at what SSP 5 suggests, we get a low of maybe 6 degrees Fahrenheit and a high of just a little under 14 degrees Fahrenheit increase, again by 2100. But notice the baseline is different from the U.S. Geological Survey. One of the things that has been a source of some frustration to me over the years is all of the folks who develop projection graphs don't use the same baseline. Every outfit that does this seems to have their own little peccadillo, and they want to use their own historic period. And so if you recall, USGS was using 1981 to 2010, I think it was. But OCRE uses 1950 to 2014. But it really doesn't matter. What you can see is the projections are very similar to the ones that we saw for USGS. Now let's look at, we're back now to the United States Geological Survey. One of the things I didn't mention is you will see along the bottom of every graph that I've stolen from somewhere, you can see, if you want to go and check me out, you can go to this URL and you can actually see the data. But what you can see is here is the summer trend, and summer, June, July, August. Summer, we're looking at, this is change in, notice, we're looking at an increase in temperature during the summer of potentially, good grief, look, 14 degrees Fahrenheit. On the other hand, if we look at winter, the increase in temperature is, dare I say, only 9 degrees Fahrenheit. The reason that I included this chart here was to demonstrate that as we go through the century, again, if we follow that absurd worst case scenario trajectory, we're looking at summers that are going to get incredibly hot. Winters warmer, but not quite so stunningly warmer. What I want to do now is, and I'll shoot through a series of graphs relatively quickly, because what I am doing here is I'm taking you down to Southern Oregon. We're going to go across the series of counties in Southern Oregon, then we'll move up the state a bit further, and then we'll move up to Northern Oregon. And what I want to do is have you look at how the trends are different as we go inland from the coast. And so here we are looking at Curry County, which is, as I'm sure anybody who spent any time in Oregon will know, is on the coast. And so what we can see here is by the end of the century, Curry County is looking at maybe a little over 8 degree Fahrenheit increase. If we follow the worst case SSP 5 scenario, it could be as much as 14. Let's now look at Malheur County. So I've now taken you right across the state to southeastern Oregon. And you can see there, the median is over 10 degrees, and the range takes us up to over 16. What's that? Maybe 17 degrees Fahrenheit increase. And as I show you the various tiers of counties, what you'll see is this pattern pretty much holds steady. The further inland you go, the greater is the increase in temperature. So now we've gone up to Lincoln County, and again you can see 10 and about 14 as the 10 is the median and 14 is the extreme. Marion County isn't far inland, so it's very similar. But if we go all the way over to Baker County, now we're at over 10 and well over 16. And now I'm going to entertain you with the tier of counties that will include Portland, because my suspicion is the largest chunk of folks who are here are from the Portland area. I could be wrong about that, of course. And so if we're over in Tillamook, you can see over 8 degrees, up to close to 14. Multnomah, over 10 to over 14. Wallowa County, well over 10 to well over 15 degrees. And so again, that trend, as we go inland from the coast, the trend is for the inland counties to exhibit or experience, by the end of the century, a much greater warming than the maritime ocean counties. And that's not surprising, because if you spend any time thinking about the climate on the coast versus inland, what you will probably appreciate is that coastal climates they tend to be not as cold in the winter and not as hot in the summer. That maritime climate is a very, very effective at ameliorating extremes. Let's take a look at Oregon precipitation projections now, because anybody who's paid any attention to climate trends will know that temperature is one thing that's impacted, and precipitation is the other. And I see Mark Gamba. Hey, Mark.
Hey, Alan. Great presentation. Touching back on your the point you were just making about the coastal areas being more moderate because of the ocean effect. At what point are we expecting the sort of world pump of the differentials in the ocean temperatures that cause the various currents that are what give us that cool water off the coast of Oregon? At what point in this do we expect that to shut off and therefore to dramatically reduce the effect of moderation of temperatures?
Well, I think if I'm understanding the recent reports, there is an extent to which that is already happening in the Atlantic. The Atlantic meridional overturn is tending to be affected. What is happening is, interestingly, the melting ice from Greenland ice sheets, this melting fresh water, is flowing into the North Atlantic Ocean, and that tends to float on the top, and that slows down the overturn rates of those currents. And if anybody saw the frightening movie Day After Tomorrow, which came out, what, 5 or 6 years ago, that was a movie, science fiction movie, which was kind of based on as all good science fiction does, they start with a germ of truth, and it was based on the expectation that the Gulf Stream was being slowed down by that ice water melt from Greenland, and if that happens, that will throw Europe into a really seriously cold spell. But I think it's beginning to happen now, Mark, but I don't know if there's a specific expectation of when it's really going to take over. But it's something to be concerned about, I would say.
Yeah. And then just since I've got the mic, and I hope to not do this again, early in your presentation, you were showing the graph of precipitation not really showing a trend. I'm wondering if it would be valuable to pick that apart and to look at two things. One, when is that precipitation occurring during the year, and in what sort of magnitudes, right? If we're getting the same amount of rain, but they're all in these atmospheric rivers, which the ground can't absorb fast enough, but it's the same amount of rain. Is that very?
Yeah, I'm gonna show you that in just a nanosecond.
Okay, perfect.
If you know, if you can,
I'll shut up.
if you, okay, that's okay. I love having conversations. Okay, so here's the overall average Oregon precipitation according to the USGS's 20 models, and what you can see is, yeah, you may remember I showed you OCRI. Well, I didn't show you OCRI. I will in a second. The Oregon Climate Change Research Institute projections. You can see maybe a hint of increase in precipitation over this period of time. And here's the OCRI, which shows you basically the same thing. A slight hint of an increase in precipitation. I think what I was showing you before was the NOAA data, which showed a historical slight increase in trend, which I suspected was not statistically significant. But you can see here the Oregon Climate Change Research Institute projections suggest that there may be a slight increase in percent precipitation. And again, this is average over the course of the year. You can see the historical data are depicted here on the left-hand side. Oregon precipitation change in values, projections compared to the 2075 to 1990 average. Again, okay, so what we're looking at here is overall. Now let's look at summer. And this is what Mark was looking at. What you can see here is precipitation change patterns should suggest during summer there may be, if anything, a slight drop in precipitation. And this is certainly the same trend that we see when I talk to folks down here in Jackson County. We see the same thing. And the response I often get is, but it hardly rains at all in the summer anyway. And the response is, you're exactly right. And I will talk about that pattern in a few moments. That's exactly right. But as we go through the century, there's likely to be an even less summer precipitation, which you can probably appreciate is potentially serious for agricultural systems, and not only that, but for forestry systems. Now I'm tending to start talking about implications, which I promised I would do next time. But you can see a really serious problem for wildfire if that indeed is what comes to pass. On the other hand, if we look at winter, and I'm guessing this might incorporate what Mark was asking about, the atmospheric rivers. What you can see is, if anything, a slight increase in precipitation during the course of winter. So winters may be wetter and summers may well be drier as we go through the century. And what's interesting is, I think, whether you look at the blue line, which is the SSP2, or the red line, which is the SSP5, you can see the trends seem to be occurring in both of those trajectories into the future. So whether we are smarter than we are now or not smarter, we're likely to see in summer a reduction in precipitation, in winter an increase in precipitation. Now, another thing that's interesting to look at is trends in extremely hot days. If you've lived around the area for any length of time, you might have been noticing this trend. From 1979 to 2022, this is the number of heat days, and I picked Portland because I suspected a bunch of people from here might be inhabitants of Portland. So from 1979 to 2022, an increase in the number of extremely hot days of, and I think this is over 90 degrees Fahrenheit, of 10. And if we go down to Eugene, it's even more surprising. The increase is up to 13 days. So Eugene is experiencing a much greater increase in the number of really hot days than is Portland. We're going to slightly different parts of the state now. Here's Bend, an increase in 4, and I included Medford because that's the closest large town to where I live. And over that period of time, the increase has been some surprising increase of 18 days in the number of days over the course of a year that exceed 90 degrees. Now, I want to look into the future. And I don't have a very high resolution image for Oregon. This is actually an extraction from a map that was of the whole world. And so you can see I've already taken a small segment out of a large map, expanded it, and what you can see is the resolution is really falling down by the wayside. But this is the history. Number of days over 95 degrees now. And this is supposing we have an increase of 1.5 degrees centigrade. I think what you can see here, and let's try and have a look at the Northwest. You can see on the left-hand side, there's certainly some areas that are red, but if you look on the right-hand 1.5 degree centigrade increase condition, the number of the area that's in the red in the increasing number of days over 95 degrees, you can see is picking up. And look at, I would say it's worth looking at the projections down for the southern states, Southern California, Texas. You can see they're up to a vast number of days over 95 degrees. So let's at least thank our lucky stars we're not living there. If we go up to 2 degrees, again, you can see the amount of red on the left is picking up even more, not surprisingly, of course. And for 3 degrees, the amount of red in the Northwest is really picking up. And so what we're anticipating is, and again, this assumes we're following the stupid trajectory, we're looking at a substantial increase in the number of days over 95 degrees Fahrenheit. Now I want to show you something about the county in which I live, which is true for much of Oregon, which I'll show you in just a second. And that is, when we look at Jackson County average precipitation in inches, what you see, this is annual, what you can see is the pattern that is very typical of this kind of a climate. Our winters are wet and our summers are dry. If we impose on top of that now the temperature, what you can see is our summers, not surprisingly, are warmer than our winters. I mean, I show this chart and I'm likely to say, duh. Well, yeah, who's surprised by that? But this particular pattern of precipitation being very low in summer but high in winter is unusual. It's called a Mediterranean climate. And what I'm showing you on the left-hand side here are different parts of the country. The top is Louisiana, and what you can see is, again, a big surprise, it's warmer in summer. But notice precipitation over the 12 months is not totally consistent, but it's much more equal across the course of the year. And then now we're looking, next one down is in Colorado. I think that's Boulder, Colorado. The text on my screen is very small. I can't quite read it. What you can see is, yes, it's hotter in summer, but notice precipitation peaks, in spring. But there's precipitation happening in pretty much every month of the year. And then the bottom chart is in New York. Again, same temperature pattern, of course. But again, you can see maybe there's a slight drop in precipitation, in January, February, March. But throughout the rest of the year, the precipitation is pretty equivalent. So we don't have this profound Mediterranean climate that Jackson County experiences. And that is particularly important for a number of reasons. It occurs, interestingly, in about 6 places across the planet. Of course, folks who grew up in Southern Oregon think, well, this is normal. They don't have any idea that this is such an unusual climate. It occurs in southwestern and southern Australia, on the western coast of South Africa around Cape Town, western South America, and western North America. This is a climate which is pretty typical throughout California, Oregon, even up into Washington. Historically, during late summer, soil and vegetation dry out. This has been going on for millennia. Fire risk inevitably increases as soils and vegetation dry out. Particularly in dry forests, fires historically in Jackson County, fires have historically occurred about every 10 years. That's called the fire return interval. So what that means is if you're standing in one spot in the dry forest of Southern Oregon, you are likely on average to experience a fire coming through there every 10 years. The results of this sequence of events is the surviving vegetation has become fire prone, and as a result of those frequent fires, the forest, the vegetation that remains is adapted to fire. The species that survive there are species that are adapted to survive in fires. In the case of trees, for example, the trunks are very thick and resistant to fire. And so the whole system becomes fire dependent. In other words, if the fires are suppressed, and I will talk about this next time, if the fires are suppressed, then the entire ecosystem becomes invaded by species that are not fire tolerant or fire adapted. And I'll talk about how that again increases the risk of fire. Now, let's look at Oregon as a whole. And what you can see is Oregon as a whole, this thing that we're looking at is called a climograph. So this is pretty much where we are now. Again, you can see, it's warmer in the summer. And what you're seeing here is the different SSPs over that immediately forthcoming 25-year period. Now, if we go towards the end of the century, that climograph shows exactly the same trend. And what you can see, again, the range in warming in the winter is, but about 8 degrees Fahrenheit, whereas in the summer, again, it's maybe 12 degrees Fahrenheit. So warming in the summer as we go through the century is going to be greater than in the winter. So that's the temperature pattern, exactly the same as I just depicted for Jackson County. And now if we look at Oregon mean precipitation, you can see again the same trend that I depicted for Jackson County. And so Oregon as a whole has a Mediterranean climate. So we as a whole have this climate where the vegetation pretty much across the state is adapted to fire conditions during the summer. And as we go on through the century, those conditions are going to become worse. And again, I'll talk about that more next time. The other thing, and Mark was asking about this, the other trend, besides when we look at averages over the course of the year, we're missing firstly the seasonal pattern. But the other thing we're missing is the daily pattern. What we're looking at here is trends in pattern in light, moderate, and heavy precipitation. So light precipitation is dropping and heavy precipitation is increasing. Reduced light drizzle days, increased heavy downpour days. And Mark mentioned the infamous atmospheric rivers, and we can imagine they are somewhat responsible for this trend. And what we're doing here is looking towards the late century. This is an image of natural trends coming from the National Climate Assessment Report. And again, you can see what's likely to be happening is an increase in those heavy downpour days that don't actually result in replenishment of soil moisture. They result in landslides and floods. Whenever I talk about climate projections in Southern Oregon, one of the favorite slides that the audience members enjoy is this one. This is looking at future summers for Medford. So this is a site where you can look at various places around the country, I think it is, and you can look at what the climate is going to be like as we go through the century. Again, assuming we're not smart. And so for folks in Medford, by 2050, the climate, summer climate is going to be like it is now in Redding. By the end of the century, somewhat like the climate down in Delano, Texas. And if you don't know where Delano is, it's right next to Bakersfield. So that's what future summers are likely to feel like if you live in Medford by 2100. And I think from folks from across Oregon, something like this is going to be the case. The future summers are going to look like or be the same experiences as locations far to the south of where the cities are today. Okay, so that's my summary of climate trends and projections. So now, if anybody has any questions, I'm ready to give it a shot and see if anybody would like to have a crack.
I would expect that the cover of forests would make a difference on the rainfall in their areas. And it feels to me like the coverage that we have of the ground in the canopy is actually decreasing over time.
Yeah, that's a very interesting observation. There's no doubt that areas that are forested are tremendously effective at processing water in the immediate area. So the trees transpire and precipitation is greater in an area which is forested than an area which is grassland. So if we can get trees to grow somewhere, we are very much likely to assist in the increase in precipitation in those areas. And as you probably are aware, one of the things that folks try and do in arid zones is to get forests growing so that they can do this water processing and increase the humidity and precipitation in those local regions. But I think you're right, and I will be talking next time about the implications of these trends for our forest species, because as you might expect, many of our forest species are likely to be seriously compromised by the climatic changes that we are imagining will be happening through the course of the century.
Well, Alan, I thank you for your time here, and this has been very, very informative to me. And obviously, our world society has a lot to do to address this. And it'll be great to hear you next month.
Next year.
Next year.
Yeah.
And
right. Yeah. And I if I can, before we close, I do want to stress the point that I tend, when I'm doing presentations, I tend not to make this point enough. I may have made it too much this time. We don't have to be this stupid.
right.
Well, we seem hell-bent on being that stupid, though, unless something changes.
Some of us, for some of us, that certainly is the case. And some of us seem to be incredibly committed to being that stupid.
Yeah. One thing I'd like to ask, Alan, there's been a giant migration of people from the north to the south. Phoenix has grown into the 5th largest city in the country, and it's growing like topsy. We have a place down there, and we spend a few months a year out, and the temperatures there are really, by Oregon standards, just completely unbearable in the summer. And you wonder
totally.
what does this portend? Yeah, that last year they had the previous record for consecutive days over 100 was like 70 some. And last year they broke that record and went up to 115. Usually you break a record by a day or two. They just blew through it. But you wonder what that's going to do for the movement of peoples in the future. They're going to find it so inhospitable that they eventually reverse that migration and start heading north.
I think my guess is I suspect it's already happening. Kathy and I have a daughter who lives in Tucson, and she actually enjoys it there. It's not quite as bad as Phoenix, even though it's further south.
Close.
It's close enough, and yeah, their summers are really, and the charts that I was showing of the number of days over 95 degrees down in the southern states were just amazing by 3 degrees centigrade increase. Yeah, so we advised there was a point when we had I think we have 3 daughters, and all 3 of them were living in Arizona, and we strongly advised them not to buy land.
I know here in Eugene, I've seen more and more Texas license plates, and I couldn't figure out what was going on there. At first I thought, well, maybe it was just all the football players coming up here to play, but I from other southern states too, that they've since I moved here, and I moved from up closer to Portland, but there's been more and more southern state plates showing up, and I suspect they're moving here.
They could be climate refugees. They could also be Democrats getting the hell out of the state.
Well, that thought crossed my mind. That would be a good excuse to leave if you were a Democrat.
Unfortunately, we need more of them there, is my judgment.
Thank you, Alan. This has been sobering.
Yeah.
Okay.
Also.
Okay, well, I'll see you next year.
Yeah,
Thank you,
we'll
Alan.
look
We
forward
look
to it,
forward to
Alan.
that.
Thank you very much.
Okay,
thank
it's
you.
a pleasure. I like doing these presentations, even though the content sucks.
Understood.
Well, if we don't get that figured out, we'd be in worse trouble yet.
Yeah, it's true.
Mike,
Okay.
I do have a question. How can we get the recorded version?
Well, that's just what I was going to go to.
It'll be posted to YouTube later this afternoon.
You have that under control?
Yep.
Okay, okay, good. So you posted on the on our webpage, Adam? Can you do that?
I appreciate it.
To our YouTube channel and to our webpage. Yep.
Okay,
Thank you.
thank you. And we'll have the PowerPoint on our webpage too.
Okay,
So-
and I would be delighted to put a link to your video from the SOCAN website.
Great.
Okay, how would you do that? Post it on our webpage, Alan?
Well, if I have the link, I can just put on our blog. I can just put a link to it.
Okay. So we'll send you a link
Yeah.
to the web. Okay.
Great. Thanks a lot, Mike. That would be great.
Thank you, Alan. This was great.
Okay,
very
thank
good.
you very much indeed. See you next year. Have
Yeah.
good holidays, everybody.
Same to
Yeah.
you, Alan.
Yeah, Happy New Year.